Okay, so this is booklet 1 of the practice exam, okay? Determine if the relationships represented below are linear or quadratic and justify your reasoning, okay? Let's look at the first one here, 5x minus 3, okay? There's a couple things going on here. I see, you always kind of want to ask yourself, what happens if I plug in x equals 0, right? So in the event that I plug in x equals 0, I'm going to spit out a y value over here, right? So in this instance, if I plug in 0, 5 times 0 is 0 minus 3. That's what's known as the y-intercept. Because when I plug in 0, that cancels. So my y value is negative 3, right? So the next one would be to, okay, well, I'm going to plug in 5, right? So my first one here, let's just keep a little track here. We could put in negative 3. These are the y values, right? And then I'm going to plug in 1. Well, 5 times 1 minus 3 is going to be 2. So we can keep track of that, okay? And then we can do the next one. 5 times 2 minus 3. Well, 5 times 2 is 10. Minus 3 is going to be 7, okay? And we'll do one more. 5 times 3. So 5 times 3 is 15. Minus 3 is going to be 12. So these look like, well, we could draw a table of values here where we have x and y, and we're going to put in 0, 1, 2, 3. And if we look at what's happening to the y values, they seem to be increasing by the same amount every time. And that is what the definition of a line is when the y values are increasing by the same amount given some x, right? So a change in x, sorry. So we get 5, 5, 5, right? So because these are the same, we know that this is a line, right? Or linear, okay? Now, another simple explanation would be to count the number of x's. This would be like a shortcut because that was a lot of talking. We can count the number of x's that exist in the equation that we're looking at. And that could be useful for some things, and we can use that approach to do some of these, right? So there's 1x, so I know it's linear, right? So there's 1x, linear, okay? Now, the next one's not as easy to see, so we'll skip over that for a sec. But let's apply the same logic we just did in that question. This looks very, very familiar, or it should. That is a quadratic written in factored form. I see 2 factors. And the other thing I see is also, I see 2 x's. So then I must know that it's quadratic. Right? And the proof is, if I were to plug in x equals 0, I could get 2 different answers. And that's how I know that it's quadratic, right? So if I check, if I were to plug in x equals 0, right? That's what we want to check. And what the y value is. Okay, well, or sorry, not x equals 0. Sorry. We want the x-axis, so when y equals 0, right? So up and down, when I cross the x-axis, the y values are 0, okay? So that simply means if I do 0 equals negative x minus 2 times x plus 3, well, there exists 2 different x values where I can get an answer of 0, right? So if I say x equals 2, right? If I plug in 2, I'm going to get 2 minus 2 is going to be 0. 0 times x plus 3, it doesn't matter, right? That's still 0, so that one works. Now, if I plug in x equals -3, right? Well, I'm going to get -3 plus 3 is still going to be 0. 0 times whatever is over here is still going to be 0, so it works. So because I get two different values of x, I know it has to be quadratic. And that's my reasoning. But also a simple reasoning is just simply because I count two x's over here, right? And then again, if we come down here, we can use the same principle. I see two x's, or an x squared out front, which we also know represents a parabola, and a parabola is a quadratic, right? So I could have factored this and found the two numbers that work. Again, these two numbers would have been taking me to factor form. And then I also know that this is quadratic, right? And that's kind of the shortcut way, right? So you could say, okay, well, this looks factorable. Factoring gives me two answers again, just much like this one did, and therefore it has to be quadratic, right? But I also see that there are two x's. X squared. X squared is always a parabola, right? So for the same reasoning, right, as above, and then we can go back, we'll go back now and deal with some of the table values, right? So if I look at what's happening with this one, when we do some of these, we have what are known as first and second differences, right? And then we can create a table based of this. We'll go down the middle, right? So what's happening from 6 to 11? Well, I'm going to increase by 5, okay? And then I'm going to increase by 7. And then I'm going to increase by 7. Sorry, 9. So, and then I see that these are not the same, which isn't a problem. But if the first differences aren't the same, then I want to keep going to the second differences. So I'm going to do this again, right? So the difference from here to here is 2. From 5 to 7 is 2, and from 7 to 9 is also 2. So then I see that it's quadratic, right? Because the second difference is the same, are the same. Okay, and then I can come down here and do this one. This one looks kind of easy, or easier than the other one. You can kind of see the pattern right from the beginning, right? So I can see just by looking at this quickly, right? I'm going to increase by 3, 3, 3, right? So my first differences are all the same, and therefore it's linear, right? First differences are the same. Okay. And then I can come down to this one here. An electrician charges $40 to look at your electrical panel and then $60 per hour to fix it. Okay, so this is basically what's going on. Somebody's going to come in. You can draw a little graph too, right? So before anybody, where time is here, sorry, and money. So before anybody even comes in, or when they come in, they're gonna charge you $40 just to look at it, right? And then the amount of time that they spend after that is gonna cost you $60 every time they come in to look at it. As time goes on, the amount of money you're gonna pay is just gonna keep increasing by the same amount, 60, right? That's the important part. So this looks like a line because every time I go up, I'm going to pay $60 more and $60 more and $60 more, right? So the rise over run in this instance is we're going to go up 60. You're going to pay $60 more than 40 and over for 1 hour. So I probably went up a little bit too far. The line should be doing something like this in this instance. Okay, so that's basically the gist of it. You can look at this one and say, okay, I know I'm going to pay $40 regardless of how long they spend in my house, right? And then, depending on how long they spend in my house, I'm going to spend $60 per hour. So that's